Okay, this is a super condensed lesson on probability, and I'm going to put down any sharp objects since I'm going to be moving fast. We're going to teach you several probability terms, make sure you get the difference between experimental and theoretical probability, and show you how to use contingency tables. All right, so here we go. First off, it has to be random. If you're doing probability where you get to pick stuff ahead of time, that's not random. All right, so basically, you can't predict what's going to happen. Like, for instance, flipping a coin, that's random. For instance, rigging a deck so that you know what card is there, that's not random. All right, event, that is something that could happen. Like, for instance, like you're flipping the coin, what could happen? Well, you either get a heads or you get a tails. All right, so those are the outcomes, the things that could happen when you do your little experiment. All right, next up, sample space. That's all the things that could happen. So for instance, rolling a die, a 1 could happen, or a 2, or a 3, or a 4, or a 5, or a 6. And flipping a coin, well, you could get a heads, or you could get a tails. This is the sample space. It's basically a list of everything that could happen. So let's say you're flipping a coin twice. Well, you could get heads, heads. You could get heads, tails. You could get tails, heads, or you could get tails, tails. That would be an example of flipping the coin twice and all of the sample space. These are all the outcomes that could happen. All right. The probability is the measure of the likelihood that an event will occur. And this is really important. It only can be between 0 and 1. If you have a probability of 0.98, that's 98% likely. You can't go above 1. All right, probability is basically what you want over what's possible. The outcomes that you want over the outcomes that are possible. All right, moving on. So if you roll 2 dice, here's all the different things that could happen. And they use 2 different color dice to make it obvious. All right, so 7 is the most likely thing that would come up on 2 dice. And that has 1, 2, 3, 4, 5, 6 different ways you could make that out of, if you add all of these up, there's 36 different things that could happen. So the probability of rolling a 7 is 6 out of 36. Okay, the probability of rolling a 12, the only way you can get it is this one way. So 1 out of 36. This is all the different things you could get in a deck of cards. All right, so those are all the outcomes. If you shuffle it, that makes it random. Then you can grab a card, and these are all the different outcomes. Therefore, that's called the sample space. All right, moving on. Experimental probability is basically what's supposed to happen. When you flip a coin, I think you know that you have a 1 in 2 chance that you are going to get what you would have predicted. Like, I think it's going to be heads, and you flip the coin. That's a theoretical probability, all right? So it's all the different things, the outcomes you want over the outcomes that are possible. And this want over possible is essentially what probability is, okay? Experimental is where if you actually take a die and you roll it, roll the die, and what if it comes up 5 more often than it should? Like a lot more often than it should. Then you might think it's actually a weighted die. And so therefore your probability of getting a 5 might not be 1 out of 6. It might be more than that. So when you actually do an experiment and you find out what your numbers are, you can see what you would expect then to happen based on the experiment. All right, next up, contingency tables. So this is a contingency table, and there's quite a few things that are important about this. One of them is all of the possible people. They totaled 100 people that they polled. All right, what if they only asked left-handed people? That would have been 13 people, okay? How many of them were male? 43. How many female? 44. Nope, I'm wrong. How many males? 52. There we go. That was right-handed males. How many females? 48. Grand total, again, 100. And so typically, how do you use these? Well, let's look. What's the probability that a person polled was female? Well, then is it 87? Well, no, there's female right here, and if you read across, there's 48. So then it was 48 of them are possible. No, sorry, 100 are what's possible, and there is 48 are the ones that you would want. So it's 48 out of 100, which of course is 0.48. What's the probability a randomly chosen male is right-handed? All right, already they're getting tricky, and this was called a contingency. Contingent upon us choosing a male means that I can't just kind of like randomly pick. I have to pick only from the males. All right, so a randomly chosen male, that means I'm picking from the males. All right, so here are the males. And if I'm only picking from the males, then I get a right-handed person. That's 43 out of 52. So notice that this says not just randomly chosen person, randomly chosen male. All right, so that changes what's possible. Instead of 100 possible, it's 52 possible because we picked from the males. All right, so it's 43 out of 52. And what's the probability a person is left-handed given the person is female? All right, given that they're female, well, then that's this. I'm going to circle just these. We know that that's what's possible. I always like to start with the bottom, what's possible. Then, given that the person is, wait a minute, given that the person is female, that's what's possible, good. What's the probability that the person is left-handed? Okay, so if I can only pick from the females, then where are the left-handed ones? Right there, so it's 4 out of 48. What's the probability a person is right-handed or male? Or increases your probabilities. Ors have big answers. I want you to try to remember that. Okay, so probability that a person is right-handed or male. So we're going to have to assume that they let us pick from everybody. So there's 100 people that are possible. And right-handed or male, well, here's all the right-handed people. And here's all the males. But what would be the problem if I put those together? Then it'd be 87 plus 52. Do you get that that's not possible because you're going to get an answer that's more than 1.0? Really, this is a really uber tricky one then. So 87 people are right-handed. So there's either those or male. Well, then these guys must be what they're talking about. These are left-handed males because why can't I count the right-handed males? They've already been counted in that group. Okay, so it's 87 plus the 9 out of the 100. Okay, moving on. We have made it to the end. You have learned the basics, and I apologize for going so fast, but I'm trying to do these in a really condensed style. Have a great day.